Hello students, today we are going to do the subtopic energy. If you are asked to define energy, then we can say easily capacity of doing work is known as energy. To do more work, we need more amount of energy. The work done on a body in changing its state, position of motion is said to be the energy possessed by the body. We can write number of examples, but some of the very common examples are: if a body is moved from the ground to a height, the work done on the body against the force of gravity and the body at the height is said to possess the energy, which is known as potential energy. The second example is, if a body is initially at rest and is made to move, then work is said to be done on the body, and the body in motion is said to possess the energy equal to the work done on the body. And this type of energy is kinetic energy. SI unit of energy is joule and CGS unit of energy is erg. If you are asked to write a relation between SI and CGS unit of energy, then we can write the relation as 1 joule is equal to 10 to the power of 7 erg. A body is said to possess an energy of 1 joule if a force of 1 Newton makes the body move by a distance of 1 meter in the direction of force. Very commonly you are given in the examination the principle of conservation of energy, and please make sure that you write the full statement for principle of conservation of energy. So according to principle of conservation of energy, energy can neither be created nor can it be destroyed. It simply gets transformed from one form to another. The sum total of energy in the universe always remains the same. You can be asked to have the energy transformation shown or the energy changes in various appliances to be shown clearly. So the correct transformation of energy should be shown by you. Some of the examples I am giving you, like if you are given an electric motor, then the energy changes you are going to show as the electrical energy will be converted into mechanical energy. In a dynamo or electric generator in use, if it is mentioned, then the energy change will be mechanical energy to electrical energy. In the generator, if nothing is specified, it's not mentioned that it is in use, then the energy change you are going to show different than the one which we have shown in point number 2. If simply it's mentioned energy change in a generator, then you'll be showing chemical energy to mechanical energy to electrical energy. If the appliance given is electric iron, then the energy change will be electrical energy to heat energy. In a loudspeaker, it will be electrical energy to sound energy. In a microphone, the sound energy will be changing to electrical energy. It will be the reverse of a loudspeaker. In a cell, in use, the chemical energy will be changing to electrical energy. In a battery, if we are charging the battery, then the energy change is going to be shown like electrical energy to chemical energy. That means in our mobile batteries and all, always we put the mobile for charging, meaning we supply the electrical energy and that gets converted into chemical energy which gets stored inside the battery. A glowing candle, the chemical energy will be changing to light energy. If you are asked the energy change in a glowing bulb, then the electrical energy will be changing to heat energy first and then to light energy. A photocell, the light energy will be changing to electrical energy. In a nuclear reactor, the nuclear energy will be converted into electrical energy. In a washing machine, the electrical energy will be converted into mechanical energy, which makes the motor of the washing machine move. So, electrical energy to mechanical energy. A moving pendulum, you'll be showing always the potential energy changes to kinetic energy and kinetic energy to potential energy. That means it is going to be a reversible change shown. Potential to kinetic and kinetic to potential. And in a ceiling fan, the electrical energy will be converted into mechanical energy. So there can be number of examples where you can be asked to show the energy changes. So the major change has to be identified, right? Or should be written in your examinations. The subtopic, mechanical energy. We can define mechanical energy as the energy possessed by a body due to its state of rest or the state of motion. The mechanical energy can be given in two different types or two forms, the potential energy and the kinetic energy. The total mechanical energy of a body is the sum of the potential energy and the kinetic energy. A very common example, a car in motion, an arrow on a stretched bow, a swinging pendulum, moving arms of a clock are the very common examples of mechanical energy. Now one by one we are going to define the potential energy and kinetic energy. First, the potential energy. The energy possessed by a body due to its position or due to its state of rest is called the potential energy. And this is the energy stored on the body when work has been done by a force in bringing the body to the state of rest or position. And very common example is a stretched bow has potential energy stored in it due to the deformed state, which is equal to the work done in stretching the bow. We can take the second example as when a spring is compressed, the work done in compressing the spring is stored in the spring due to its deformed state in the form of potential energy, and the compressed spring is said to possess elastic potential energy. The potential energy is of two forms. Number one, elastic potential energy, and the second one is gravitational potential energy. Elastic potential energy is present when the work done on the body changes its dimensions, or we can say it is due to the deformed state of the body. Whereas the gravitational potential energy is possessed when the work is done to move a body to a height above the earth's surface, or we can say due to the position of the body above the ground. If you are asked to write the expression for gravitational potential energy, then we can write P E is equal to mgh or U is equal to mgh, where PE can be taken as potential energy or U can be taken as potential energy. M is the mass of the body, G is the acceleration due to gravity, and H stands for height above the ground. SI unit of potential energy is joule, whereas the CGS unit of potential energy is erg. If you are asked to write the relation between the two, again you will be writing the same way. 1 joule is equal to 10 to the power of 7 erg. Factors affecting the potential energy. In that case, you will be writing there are three main factors on which the potential energy of a body depends. Number one, the mass of the body. More the mass of the body, more will be the potential energy possessed by the body. Second one, the acceleration due to gravity, more the acceleration due to gravity, more will be the potential energy possessed by the body. And the third one is the height above the ground, more the height of the body, more will be the potential energy possessed by the body.